Hey everybody. In this video we're going to be looking at section 2.6, skewness, and then mean, median, mode. So in this section we're going to be determining what's the best appropriate or the best measure of center, mean, median, mode, and then looking at different distributions, uniforms, symmetrical, skewed, and bimodal. And here we have a perfect symmetrical distribution of data. It's centered right down the middle. The highest column is in the center. Then it levels off beyond that. So in a perfectly symmetrical distribution, the mean, median, and mode are all right down the middle. And if you took the average of these numbers, you'd find the mean would be right down the middle, and the median, the number right in the middle, is right down the middle, and the mode, the tallest column, is that obvious one right down the middle. On the bottom here, it says if we have two modes, it's called a bimodal. And this one only has one mode, though. Now we're going to get to skewed data displays. And skewness is referring to the side that has extra data. And this one, if we look, here they talk about how it's been chopped off. And this is called skewed to the left because it's been pulled out, it's been stretched. The extra data is on the left-hand side. That extra data on the left-hand side is going to bring our average down. So it's going to lower the average. The median is going to be right down the middle, somewhere right in here. The mode will be the most common right here, 7. The median would be somewhere here, in the 6 range. But then the mean, the average, would be a little bit lower than the median, maybe like 6.4, when the median would be 6.6. So the point here is these on the left drag the average down a little bit. And just the opposite is on the right. When we're skewed, this is called skewed to the right because there's extra data on the right. This is going to increase our average. So the average, the mean will be the highest. The median would be somewhere in here. And then the mode would be the furthest to the left, the smallest, because that's the tallest column. Let's discuss the mean, median, mode for each of the following problems. Here the mode is the most common, so 1. The median, well, we could even count these, top 20. So if there's 20, we need to find 10 on each side and then take the average of the two. So 2, 4, 9. There's 9 here, 10. So there's the first 10, and then here's the other 10 over here. So the median would be somewhere between 3 and 4, so 3.5. Then the average, shoot, I should have calculated this ahead of time, but the average is going to be a little bit bigger than that. So if the median was 3.5, this has been skewed to the right just slightly because we have these extra points over here. The average would probably be like 3.9 or 4 or something like that because this has been skewed to the right. This data looks fairly symmetrical right down the middle, though we do have the mode, which is going to be 6. This is the age former US presidents died. So 60, 60, 63. And this looks fairly symmetrical, but just skewed slightly to the right. So our most common data value, if we look at this, would be 67. And then our median, we'd have to count all of these up and find out the middle spot and then the mean. But this one looks fairly symmetrical, so I think to save us time, so it's all going to be fairly well clustered around the center. Maybe the average would be slightly, a little bit higher because this goes a little bit higher this way. Then our final one is definitely skewed to the left because it has a bunch of extra data out here on the left-hand side. The mode would be 20 to 24.99. The median would be somewhere here in the middle of our data, but then the average is going to be dragged down a lot because of these over here, so the average would be the lowest amongst all of those. All right, so that's it. Thanks.